just easy because I do it like while I'm studying.
Right.
Well, I see, because it's all
Right. He's
like, okay, this is fine.
So I'm like telling her, she's like, you're grossing me out. She's got this picture and she pointed to like she's like,
All right, we learned the endometrium and myometrium layers before the break, and the next slides involve showing you histology of the uterine wall. The histology, well, basically be able to tell endometrium from myometrium. If you look at the picture on the left compared to the right, which is a simple illustration, it's easy to see. So, for other structures to know, within the endometrium, sometimes I have you identify uterine glands. Sometimes I refer to them as glycogen glands because they secrete glycogen to nourish the baby, should one implant. Uterine or glycogen. Those are a big clue because you can tell by how numerous the glands are what phase of the uterine cycle you're in. So you should, based on looking at uterine glands, you should be able to tell if you're in proliferative or secretory phases. If you're in the proliferative phase, you'll see the uterine glands increase in size and number. When you're in the secretory phase, you're at kind of max level. The glycogen glands, they'll appear very large, very jagged looking. I'll just put largest. The glands are the largest in the secretory phase. And the best way is to just look at it instead of me trying to describe it to you. The other thing I'll say is that you have a lot of blood supply to the endometrium. And they are all are branches from the uterine artery, which is a branch of the pelvic artery. Well, anyways, this branches into the arcuate, which branches in the radial artery. I would say the important one to note are these spiraled arteries. The spiral arteries, they grow and proliferate with the uterus. So you'll also see an increase in spiral arteries in both the proliferative and even in the secretory phases. And those are the two things I tend to emphasize about the endometrium in terms of the physiology. The job of the endometrium is to sustain a pregnancy. It responds to the hormones, estrogen and progesterone. So estrogen and progesterone are causing both of these things. Estrogen, progesterone, they cause the endometrium to thicken, and when it thickens, that's not enough. You're going to know what's happening when it thickens. You're increasing glycogen glands, and you're increasing spiral arteries. All right, so let's look at the sublayers of the myometrium. The myometrium is down here. Notice that the endometrium is actually subdivided into a base layer and a functional layer, okay? So what I was talking about over there to specify is this layer here. They call it the functional layer, or the fancy way to put it is stratum functionalis. So this note here causes the endometrium to thicken and increase in glands and arteries. It's really stratum functionalis. It's the functional layer. That's the function. It thickens. Stratum basalis does not respond to hormones. So I'm writing stratum basalis is not hormone sensitive. So stratum functionalis is the layer that's shed if there's no pregnancy and you have menses. Okay, so it's the layer that's shed. Stratum basalis, not shed. It will remain and it'll reproliferate in the next month. So shed, not shed, basically. And then I already mentioned myometrium. Just try to identify many bundles of smooth muscle. That's pretty much how it's arranged. I already mentioned the hormone that causes it to contract in labor and delivery, oxytocin, from the posterior pituitary. So let's look at a picture here. I'll show you more when I present histology today. I should have wiped it down. There's a big dust particle there. But I put a bracket around endometrium. So anywhere below it is myometrium. You can kind of see a difference in tissue there. Okay, and the only structure you can identify is pretty much those uterine glands. They're proliferating, and I put some notes here so that students can keep track of what's going on in the uterus and what's going on in the ovary. So let me do that.
So all those are uterine glands?
Yeah, anything where you see like that little white space, you got it. Uterine gland. So 28-day cycle, more or less. 28 days. Day 1 over here. Who remembers what day ovulation is? It's supposed to be 14, so I'll try to ballpark right in the middle. So 28 days, day 1, day 14. So what I'm saying is, you got uterus, you got ovary. Well, let's start with the notion that, okay, the previous time, no pregnancy. So you get menses, okay? Menses is the monthly discharge of the endometrium, and it starts on day 28. So menses is days 28 of the previous cycle, and maybe the first 5 days of the next one. So those are the days of menses. So it starts here. starts here, menses, and maybe it goes to the first 1, 2, 3, 4, 5 days, maybe around there. So it starts here and goes all the way to here. May 28th is International Feminine Hygiene Day. Because you know, menses, it usually begins on the 28th day of the cycle and goes to the 5th day of the next. Then it's like, okay, well, let's rebuild for the next one. And so that's kind of like proliferative phase. Call it day 5 to 13. Maybe it starts there, goes right up to ovulation, let's say. So what's going on during that time? The endometrium is thickening, you increase the uterine glands and the spiral arteries, which I already said. You're rebuilding the endometrium. And then day 14, that's the most important day, ovulation. Why is it the most important? If you don't ovulate, you're not reproducing. The name of the game is reproduction in this chapter. Day 14, or there around, okay? Ovulation. That's the day, if you're going to conceive, that's the day. Because the egg is available. Day 14. So fertilization happens, let's say, and it stays in the uterine tube for about a week. The typical site is the ampulla of the uterine tube. So in basically the second 2 weeks, let's go 15 to 27. Secretory phase. Day 15, 27. So there, all the way to there. Okay, so what's happening in the secretory phase? You're thickening it more. I said earlier, this becomes a secretory mucosa. You're basically getting ready for implantation. So this is implantation ready. I'll go into more detail with what I mean by this. This is just an overview of the whole cycle. But what I did was, from menses to proliferative to secretory, those are the phases of the uterine cycle. The complicated thing is that the ovary must cycle in a way that matches this. Okay? So the ovary, the ovarian cycle, goes through a similar process with the follicles that contain the eggs. So at the beginning of a cycle, you take a cohort of about 20 eggs, and you put them through all the follicle stages that we learned before, right? Select 20 follicles, that is. And you develop them. You go through primordial, primary, secondary, Graphian, or sometimes it's called tertiary, through those first couple of weeks. Okay, and remember, you select 20, maybe one will ovulate. Okay, well anyways, This part, this first couple of weeks where I drew it pre-ovulation, that's called the follicular phase, okay, pre-ovulation. All the way up to ovulation, the most important day. So you ovulate and you get fertilization. What the ovary has to do is the ruptured follicle that ovulated, it actually becomes a luteal body. Okay, I'll show you a picture of that later. But there is a second couple of weeks, they call this the luteal phase. Because the hormone progesterone is really dominating during this luteal phase after you've ovulated. Okay. Do you remember what the follicles secreted? I taught you that. Not FSH, LH targets it, but then they secrete estrogen. Remember that?
Yeah.
Remember how I said the theca secretes androstenedione and aromatase turns it into like estrone? That whole thing? That is basically these hormones, estrogen, they're targeting the endometrium to rebuild it. They cause the rebuild. There's other ones too. Let's just keep it simple. One hormone. Estrogen in the follicular phase rebuilds the endometrium. Then you ovulate it. You have to develop it more into this phase. This phase, you're going to get the hormone progesterone in the second couple of weeks. Get your implantation ready. So it's hormones that cause all of these things. Okay. So you're ready for what? Well, you don't know what happened. Did you fertilize or not? If you did, expect implantation. If not, menses. Okay. Now, looking at the slide here, you're supposed to know this is the proliferative phase. So look at the thickness of the endometrium and look at the myometrium down there. Compare it to the secretory phase. You know, when I took this picture, the secretory phase, the endometrium is so thick, I couldn't get the myometrium in picture. So, because it's thicker here. Now, do you see all of these squiggly things? What do you think those are?
Glands?
Yeah, the glands. The spiral arteries, don't look for those on the histology. I usually don't see them. But they do look spiral shaped. They say that the uterine glands are sawtooth in appearance. Well, anyways, you can see why they call the proliferative phase the proliferative phase, because by the time you get to here, there's so many of them. And so that's the secretory phase. You can call it progravid phase. It's post-ovulation. Okay, so that's a good look at those two phases of the uterus. So I want to switch gears, and I want to talk about the uterine tube. Okay? And this is a good picture to look at. So this is why some people put repro right after endocrine. If you've noticed, you've skipped a bunch of chapters, right? We're going to go back and do the other chapters, but there's a lot of hormones in repro, so why it's good to put it now. All right, so the uterine tube. Be able to identify different regions. I'll go from proximal to distal. Okay, uterine part. Of uterine tube. It's the part that goes through the uterine wall. So it's in direct communication with uterine cavity, right? communication with uterine cavity. Moving out from that, the thin part of the oviduct or the uterine tube, also called the oviduct. Sometimes I see the term fallopian tube. That's still used. And I'll accept it. I still see it enough to say you can still use it. Mostly books will call it the uterine tube. Well, anyways, the thinnest part is the isthmus of the uterine tube. So isthmus is an adjective. It describes the part. It's the thin part, and it's right after the uterine part. You got all these parts. Wasn't something else called isthmus? You had an isthmus of the uterus. So you better put of the thing. If you just put isthmus of what? There's two of them in the same lecture. So you gotta like specify. All right, as the tube gets from thinner and widens out, they call that the ampulla. I mean, didn't we see that before too? You had the ampulla of the Vas Deferens. This is the ampulla of uterine tube. One of your first notes, made the class on time this morning, I said this is the typical site of fertilization, where sperm meets egg. Typical site of fertilization. Okay. Right after that, close to the end, is the infundibulum, which means connecting stalk. It's in communication with the ovary, although they don't illustrate it that way. We had an infundibulum of the pituitary as well. It's just a term that refers to connecting stalk. The unusual thing about the end of this tube, it's not a smooth cut edge. There's all these finger-like projections called the Fimbriae. Now you don't have to put Fimbriae at abdominal ostium, but think about it. This is opening into the abdominal cavity. Okay, so the ovulation, it's got to catch it. And the ovulation could, if it doesn't catch it, it'll just end up in a single cell in the ab cavity, and fertilization probably won't happen. Okay, so let's note the Fimbriae. Finger-like projections. Which are at the very end of this uterine tube. Hopefully you catch the ovulated oocyte and you sweep it up to the ampulla. It'll just hang out there for about a day waiting for sperm. Okay. Now, what I thought was students always like get confused about which part, where one part ends and the other part begins. And that is illustrated on the coloring plate a little bit better, I think, because they draw partitions there. So I will basically color the uterine part of the uterine tube green, the part that's actually going through the wall, right there. That's super important. Sperm have to go one way to fertilize, and then the ovulated blastocyst has to go the other way through that part to get into the uterine cavity. So it's the part that goes through the wall. And so where they color isthmus, they put a little partition line right here, right before, as it starts to thicken. that's a pretty good way to illustrate it there. It's super thin. If I'm going to tag it, I'll tag it at the thinnest part. And then right after that, where it becomes much thicker, they put G for ampulla. I'm going to like draw it all the way up to here. So anywhere in there, expect fertilization to occur. Now I left that little edge for infundibulum. Now they don't use that term in the coloring plate, but I will. So I'll color a different color. Infundibulum is typically taught in a basic anatomy class. It's this end right there. Oh, they put a dotted line right there. So we'll go with that edge for infundibulum. And then the figure-like projections, I'll color red. Doesn't matter what color you use, but they're right here. That's the Fimbriae. Okay, so you are responsible for the specific parts of the uterine tube. So we were here at the uterine tube, and I wanted to put the picture next to the model that we have in the rooms over there. Uterine part, if I label it here, I'm going for isthmus, pretty much all of this is going to be ampulla. Okay? But if I put it right here at this little neck, I'm going for infundibulum. If I go for Fimbriae, I'll try to put it right at the super edge, okay, so there's no doubt. So the oviduct, okay, did it. Here's a cross section of the uterine tube or oviduct. And notice how when you cut the tube, it's not a round space. It's all these little nooks and crannies. And the mucosa can nourish the oocyte from about a day until the sperm come. If you take a close look at the epithelium, right here, that's what it looks like. So the histology of the epithelium, it's lined with, now most books will say a ciliated simple columnar ET. Epithelial tissue. And if you remember your histology, I hope you do, a simple epithelium is one layer. Okay, and it has many cigar-shaped nuclei, well, one per. And it usually has a, well, they all epithelium have a basement membrane. In cilia, you can usually spot it. Now, I look at that picture, and it looks not simple. Looks like I see nuclei stacked on top of one another. Now let's remember, that would be called a pseudostratified. Pseudostratified columnar ET. So in that one, if you recall, it has the appearance of stratification. So you have a basement membrane, and then it is a simple layer, but it appears stratified. So you have all these nuclei, looks like they're stacked on top of one another. And there's probably cilia as well. Most columnar epithelial tissue are ciliated. I'll put cilia here. Now, if it's ciliated, great, put that they're cilia. Then you just have to look. Is it simple or is it pseudostratified? This one, I would name it pseudostratified. Students always like want to press me, well, which one is it? It may be both. So what do I put for the quiz tomorrow? You put what you see. What do you see? Pseudostratified. Put pseudostratified. You're going to get it right. Okay?
Even though it says simple columnar?
Yeah. Because most books will, I'm telling you what most books will say. I've read them all. But I'm like, okay, I go to our collection. I took this picture last year. This is what I see. So it's like, that's the fun part of science. It's not always, your biology is not going to stay the same for us, I guess, right? It's just, sometimes it'll be simple, sometimes it'll be pseudostratified. I'll pull out a slide today, and you tell me what you see. I'll tell you. Okay? Very simple.
The little wispies on there, it wouldn't be ciliated, right?
It is.
On the picture,
Yeah, because it looks like
these little things right there, that's cilia.
Yeah.
It is ciliated.
Oh.
This one is ciliated. So we'll take a look later. Let's move on. Moving away from oviduct, I want to talk about some ligaments of the uterus, but also of the ovary that I didn't mention yet. So this picture can help us. Okay, look at one of the ovaries there on the left picture. I see an ovary, and I see there should be a ligament there, a ligament there. So for this ovary, there's a ligament there and a ligament coming out of there. It's hard to visualize, but there are names for them. This one, it goes to the uterus, and it's called the ovarian ligament. Your atlas calls it proper ovarian ligament. Sometimes that term is dropped. I'll put it in parentheses. And that's the supportive structure for the ovary. This is the suspensory ligament. Not always shown on our models, but it is there. It's going to attach the ovary to the lateral pelvis, and it contains blood vessels. Even though it's not shown on the picture, if you look at your coloring plate, it is shown there. I don't want to keep flipping back to that, but they do show the suspensory ligament with the blood vessels in it on the coloring plate that I handed out. It's letter M on one of them, but you can kind of look yourself. So anyways, those are two ovarian ligaments to know. Some uterine ligaments to study. Well, we already talked about one big one, broad ligament, and all its parts. I don't want to go back and teach it again, that would be redundant. But this picture here shows us other ones I didn't mention. There's one called the round ligament. In men, it was the spermatocord. females, you have this structure, it's just a ligament. It goes forward into the inguinal canal, and that's shown right here. Right in there. There's round ligament, there's round ligament on the other side. Okay? The one going posterior from uterus to sacrum is uterosacral ligament. So the name describes it, uterus to sacrum. Okay, so the picture of either of those. Now on the picture on the other side, where they don't remove the peritoneum, imagine it's inside that fold, okay? Now, the other one that is shown going transversely, it's simply called the transverse ligament. Sometimes it's called the cardinal ligament, I'm not sure why. So, transverse or cardinal ligament. Now this one, we have yet to have a model that shows it well. If I use it for a lab practical setting, I'll have to print out a picture, like this one. Okay. But it's in the transverse plane. The transverse ligament will help the uterus from prolapsing, which is to collapse down into the vaginal canal. Now what I did was I took a picture of the model in the classroom that kind of has some of these things, and I pointed to a few of the ligaments. Round ligament, proper ovarian ligament. Now inside that fold would be the uterosacral ligament. And I have a picture showing you how the round ligament is like the spermatocord in the females. If you did the dissection, I've never done this one, that ligament would emerge through the superficial inguinal ring. For men, I taught it as part of the inguinal canal. And there's the spermatocord we talked about the last time. Here's another picture showing you, well, the red arrow shows transverse cardinal ligament. I said it prevents uterine prolapse. Imagine the uterus, this can weaken and this can collapse down into the vaginal canal. One time I was doing a dissection and I reached in here and I felt this stiff rubber ring. And we reached in and pulled out this plastic ring, it's called a pezarine. In elderly, it helps prevent uterine prolapse, where pelvic structures can weaken. So it basically helps keep the uterus in the pelvis, keeps it from going down. Okay, the vaginal canal next. Shown here, everything else is grayed out. I'll describe it as, it's 3 to 4 inches. It's described as a fibromuscular tube. Shown there. Functionally, I said earlier, received penis. Hence the name vagina. Vagina means sheath. Okay? Sheath for the penis and intercourse, but also as part of the birth canal with the cervix. So, with cervical canal, vaginal canal form the birth canal. So if I point to the proximal part, be able to identify fornix. The Fornix is a 360-degree recess all the way around cervix, right here. So that's why they usually call it posterior part, anterior part, lateral part. You don't have to put that. Just put the recess right there at the junction. Proximally is fornix or vaginal fornix. At the other end, just call it vaginal orifice. So in terms of anatomy, that's it. It's the canal with fornix and orifice at the other end. That's pretty much it. Now, not a part of this region, but a part of repro is the mammary glands in the chest region, in the pectoral region, I should say. The mammary gland is attached by connective tissue to pec muscles. Okay? Suspensory ligaments are the connective tissue structures that attach the mammary glands to the pectoral region. I'll say suspend. Mammary glands to pectoral region. The milk-producing structures are the mammary lobes. Milk production. Remember, prolactin, PRL, during pregnancy will help facilitate that in the anterior pituitary. The rest you see there is fat. Now there is a duct system to let the milk down. So I'm going to note lactiferous duct. It's pointing to there. Lactiferous sinus, don't worry about that. It's kind of a artifact from cadavers. It's really not there in a living person. Just the ducts react to oxytocin to let the milk down into the nipple, which is surrounded by areola. Lactiferous ducts for milk let down. And that's the hormone oxytocin. Can't really see it in the sectional view here, but note, be able to identify nipple. And the brownish tissue surrounding that is referred to as the areola. The areola may have a bumpy appearance due to a lot of sebaceous glands that are in it. Bumpy due to sebaceous glands. I think I ended the slide set with just kind of a labels on, labels off picture of a sagittal view that you can study. But I want to transition now from anatomy to the histology slides. And what I did was, where's my hand? I made a histology study guide just like I did for the endocrine. And I put it on Canvas recently, but if you didn't print out a copy, I'll leave a stack over here. So this is for repro. Put it somewhere here. Go ahead and help yourself. Let me get ready for histology, so if you want to take like a 3-minute break, I'll start with 3 minutes.